Welcome back, guys. In the last video, we saw the working of a PN junction diode. Now today, we'll see what happens when a battery is connected to the ends of a PN junction. And there are two possible configurations. The first one is known as forward bias, and in this configuration, the positive terminal of the battery is connected to the P region, and the negative terminal of the battery is connected to the N region of the junction diode, as you can see here in the diagram. And as we already know, immobile ions are present in the depletion region. In the P side, we have negatively charged immobile ions, and in the N side, we have positively charged immobile ions. And because of these ions, an internal electric field from the positive N side to the negative P side is created, denoted by EI. And due to the battery voltage, an external electric field E acts from P to N side, which is opposite to the direction of the internal field EI. Oh, sorry. This should be E. And since they are in opposite direction, the resultant electric field is reduced. This is reflected by a corresponding decrease in the width of the depletion layer as the quantity of ions in the junction reduces. But how? Since the positive terminal of the battery is connected to the P side, some of the majority carriers in the P side, that is holes, diffuse into the depletion region. Similarly, some of the majority carriers in the N side, that is free electrons, diffuse into the depletion region and they form neutral atoms. So these ions will not be present anymore. And because of this process, effectively the width of the depletion layer decreases, as you can see here. And when the external voltage is greater than the barrier potential, the electrons acquire sufficient energy to pass through the depletion layer and travels through the holes in the P side to the positive terminal of the battery. Or correspondingly, we can say that holes travel from the P side to the negative terminal of the battery. And for silicon, this barrier potential happens to be 0.7 volts approximately. Okay. And thus continuous current flows in the conventional direction. So what is meant by conventional direction? Conventional direction is opposite to the direction of flow of electrons. So electrons are flowing in this direction. So our current will be flowing in this direction. And the basic features of forward biasing are: number one, within the junction diode, the current is due to both types of majority charge carriers, but in the external circuit, it is due to electrons only. And number two, the current is due to diffusion of majority charge carriers through the junction and is of the order of milliamps. And the other possible configuration is the reverse bias. In this configuration, the negative terminal of the battery is connected to the P region and the positive terminal of the battery is connected to the N region of the junction diode, as you can see here in the diagram. And we have already seen that Negatively charged immobile ions resides in the depletion region in the p side, and positively charged immobile ions resides in the depletion region in the n side. And the external electric field E produced by the battery voltage is in the same direction as the internal field EI. So external electric field is acting from positive to negative side, and internal electric field EI is also in the same direction. Okay, and this results in a stronger electric field, which is reflected by a corresponding increase in the width of the depletion layer as the quantity of ions in the junction increases. How? Now, since the positive terminal of the battery is connected to the n side, it attracts free electrons towards it, and similarly, the negative terminal of the battery attracts hole towards it, effectively increasing the width of the depletion layer. And because of this, the potential barrier's ability to oppose the flow of majority carriers is enhanced. So there cannot be any current carried by the majority carriers. The drift current carried by the minority carriers, however, is not affected. The electrons in p side and holes in the n side can flow in the direction of the field from n to p. But the number of minority carriers being very small, the drift current is very, very small, of the order of microamps compared to the current under forward bias. That's it for today, guys. See you in the next lecture.